Hello, I'm Sue Nelson and welcome to the Planet Earth podcast. Today we've got a touch of James Bond style science and details of the first ever map showing which UK power grids are most at risk from geomagnetic storms.
Our map is basically a very simple representation of the UK power grid. And what we do is we use the geology of the UK, because that's the controlling factor actually, to try and figure out how the electricity flows between one part of the UK and another when there's a very large geomagnetic storm.
I'm at the University of Birmingham and you can hear the clock tower that's just ahead of me. And I'm outside the university's Monroe Sports Centre. Inside, a group of scientists are piloting the equipment for an unusual experiment that's about to begin in just a few weeks' time. Now, I gave you a clue there with the James Bond-style science reference, but we're not talking gadgets here. Think back to the opening sequence of Casino Royale, where Daniel Craig's 007 is chasing a man in Madagascar. It's a thrilling scene as the man leaps from a giant crane and then skids, jumps and somersaults across rooftops and buildings and in and out of windows. It was a stunning display of a recreational running sport called parkour, also known as free running. And inside this sports centre, a parkour athlete is under scrutiny, and all for the benefits of science. Let's go through then into the sports centre in the warmth, through the turnstile and towards where the action is. Make my way through the hall. Here we go, the Slater Gymnastics Hall. And in we go. And it looks like they're having a discussion here about what exactly they're going to do.
Yeah,
Can you move?
have it at a right angle also.
Can you move this thing? Do they move?
It's not bolted down, but it's
got one.
This one is bolted down.
Dr. Susanna Thorpe from the university's biomechanics lab at the School of Biosciences is one of the team doing this research. So, Susanna, I think we better begin by basically saying, what are we doing here in a gymnasium with a parkour athlete?
We are trying to understand the locomotion of one of our closest living relatives, which is the orangutan, and also the locomotion of all of the apes and the common ancestor of humans and the other apes. And in that area, we have had a big problem traditionally in that we know a lot about how they move around the forest. I've been out to the forest and spent a year recording the different types of locomotion they use, but we have no idea about the energetic cost of how they move around the forest and the solutions that they find to problems of moving around the canopy. And what we're doing here is using the parkour athletes as an analogy for a large-bodied ape moving around a complex environment. We're getting them to move around an assault course that we've made that they've never seen before, and we're going to record their energetic expenditure while they're doing it.
It is quite an assault course too. We're right beside here a lovely, sort of reminds me of my school days, sort of vault, wooden vault there. We've got some beams over in one corner, a trampoline at ground level in another corner, some asymmetric bars, some rings, parallel bars. I mean, this is sort of perfect for you, really, isn't it?
This is absolutely perfect because there are lots of surfaces that the parkour athletes will be familiar with outside in their normal world, but inside, in our little locomotor assault course world, there are different supports that they will never have seen, and supports that we can make behave in a way that they wouldn't expect. So, for example, we have springboards that you would expect to bounce underneath their weight, and if we put solid chocks underneath them, they're going to behave in a solid way.
Which is probably what these athletes are used to, because they're more likely to be doing their feats and stunts on concrete, let's face it, not a sort of nice, softly sprung, gymnastic tailored floor.
That's quite true, yes. So the reason why we're doing this study is that orangutans and the other great apes move around the canopy of tropical forest, and the branches there are very flexible underneath their weight because the animal is so large. So flexibility or compliance is a really important problem for large-bodied apes in the canopy. And here we have lots of supports that we can make behave like branches in the forest. We can set up the assault course so that it's very complicated, as moving around a forest canopy would be, and we can confound how the supports behave, so we can have supports that appear to be stiff that we make compliant, and supports that are quite compliant that we actually make to behave in a stiff way. And that mimics the challenge that a large-bodied ape would face moving around the canopy, when they have to look ahead of them and judge how the supports available to them are going to behave without being able to test them.
The way I would do it to get the best swing is I'd jump up and backwards, reach one arm up, swing to the other side, and as I get to the end point, swing that one arm back down.
And then land.
Okay, and then land.
Okay. Wow.
Now, the athlete that's helping the scientists here is Brendan Riley from EMP Parkour. Brendan, how difficult is it to do? Because the professionals, including yourself, they make it look very, very easy, and I suspect it's not.
When you see them in the movies jumping from a crane to a rooftop, it's obviously not where you start. We start on the ground, we learn how to roll, we learn how to fall over safely, because we do fall over a lot, but that's part of the fun. And we gradually build up our skills. As you become stronger and more confident, you move into more complex movements.
It's got certain moves, isn't it? I've heard of like tic-tacs and what have you. What are the basic moves?
Yeah, there is a skill set. The founders of it would say that the moves aren't important, and actually in France, where it came from, they try not to use the names and movements too often. They will say passement, meaning vaulting, but they won't get too specific on what kind of vault. It's just get from A to B. A simple vault would be the cat pass, which is like a through vault in gymnastics. You have the tic-tac, that's kicking off a wall to propel yourself higher or further. You have speed vault, that's a really efficient vault, just one-handed, made famous by David Bell in his movie District 13. Then there's a bunch of other ones which less efficient but just as much fun. And then the main thing we do is a precision, that's just jumping from one thing to another. Or if you grab hold with your hands, then that's called an arm jump.
How do you feel then about helping scientists here examine how primates move? I assume you're not insulted by this.
Not at all. I love monkeys, I love apes. I wish I was a gibbon. I think I probably was in a previous life. Sounds weird, but we look up to primates. We look at their movements and it's very inspirational. I know some guys who have actually been to different parts of the world just to see how the monkeys move and been training with them. I think it's brilliant. It's great.
For you as an athlete, what's your advice for them in terms of modifying what they want, keeping it in terms of what human beings can actually do and by keeping safe?
Well, what we're trying to do today is set up kind of a course but not make it too obvious exactly what we want them to do. We don't want it to be too regimented. We want them to be moving quite animalistically. Like if you did set an ape free in here, what would it do? We want to set out a rough course, but we want them to move in their own individual style, get around how they want to. So we'll say, get from this end of the room to this end of the room, touch that, that and that, but that's about as much instruction as we'll give them. I'm here today just because they don't necessarily know what some of the guys are going to be capable of, so I'm going to say, yeah, they can do this movement here, and they can shimmy along that or fall off that with no problem.
How many parkour athletes then are going to take part in this experiment?
Between 6 and 10 of my guys from Birmingham, and there's also going to be a bunch of guys coming down from London.
In order to work out what the energy costs are for the parkour athletes as they complete the circuit, you need to take some measurements, and that's where Dr. Lewis Halsey comes in. He's a senior lecturer in environmental physiology at the University of Roehampton in London. So, Lewis, what are you going to measure? How are you going to do it?
So the primary thing we're interested in is the energy costs for our parkour athletes as they traverse the circuit, as they use various bits of apparatus. And we're going to measure that by measuring their oxygen consumption. So we're going to put onto their backs essentially a portable oxygen analyzer. They'll have a mask, and the oxygen consumption of the person and the carbon dioxide output at the same time is measured by this mobile gas analyzer that's strapped to their back. And that's all relayed to a computer, so in real time we can see the various costs of the various apparatus they're using. There's an added twist to this, which is at some points they may partly use anaerobic metabolic pathways, and the analyzer can't pick that up because it's measuring oxygen consumption, which is involved with aerobic pathways.
But also, I would have thought that for athletes, though, they're so fit that you wouldn't necessarily get much energy expenditure, not because they're not expending energy, not because they're not expending the energy, but because they're used to it. It's not as much expenditure as, say, you, not wishing to be insulting, you or I, if we did it.
Yeah, so that's absolutely right. So our parkour athletes, they're professional athletes, they're very, very fit, and they can do lots and lots of these exercises before they get tired, and that's really important. However, and similarly, we would presume for these primates that living in a sort of arboreal environment, they will get tired sometimes, they will build up lactate, and we have to be careful that doesn't happen too much, because then our method of measuring energy expenditure via oxygen consumption actually doesn't work.
What's lactate? Is that to do with, you hear lactose feel the burn? Is that chemical that
That's right.
That makes your muscles ache?
That's a byproduct of at least partial anaerobic metabolism. So when we obtain energy from the substrates in our body, so our fats or our sugar stores, if we don't use oxygen entirely for that process, a byproduct is lactate. And if we get too much lactate in our body, we stop working so well, we feel that burn, and we have to stop. But we can measure the extra oxygen that's consumed by the body to deal with that lactate build-up, and so still get a good idea of the energy expenditure of our athletes, even though they're going to be working pretty hard.
How long is this project going to go on? You know, how hard are you going to work your athletes?
So we're going to have an athlete a day, so they're going to be with us all day, so they're going to be pretty tired by the end of the day, doing quite a lot, but with lots of rests. So we're going to start collecting the data proper this month, and we'll carry on until March.
Susanna, it's an amazing experiment. I can't wait to find out what the results are going to be. But there's quite an important reason, isn't there, for actually doing this project?
It's important for lots of different reasons. One, from the perspective of understanding human evolution and the challenge that the common ancestor of all of the great apes would face, and also our ancestors would face when they were partly arboreal and partly moving bipedally on the ground. And secondly, from a conservation or an ecological perspective, if we understand a lot more about the challenges that orangutans face in the canopy, and the solutions that they find to solve them, and the energetic cost of doing so, then we can better construct conservation strategies for them. And they have, of course, been predicted to be extinct within 10 years in the wild if we don't do something about it. So finding the most effective way to structure a habitat, or picking the most effective habitat for them, for rehabilitants, is a good way to help contribute towards their conservation.
Susanna Thorpe and Lewis Halsey, and parkour athlete Brendan Riley, thank you all very much indeed. And I've been taking a few photographs as they've been walking around and setting up and thinking about how the course is going to go, and you can see those pictures on our Facebook page. We'll also keep you informed of how the project gets on in the future, and don't forget you can follow the latest news from all of the natural world on Planet Earth Online. Scientists recently produced the first ever map of the UK that shows which regions of the power grid are most at risk during geomagnetic or solar storms. If eruptions from the sun are large enough, these storms can disrupt satellites, communications and power supplies. Kieran Beggan from the British Geological Survey helped produce and analyse the data for the map, and he began by explaining exactly what causes these storms.
The sun can often erupt very large amounts of gas and magnetic fields known as coronal mass ejections. These are known as solar storms. And if they cross space and they hit the Earth's magnetic field, then they interact together and they basically load up the Earth's magnetic field with energy. And that energy flows down from space to the upper atmosphere, say maybe 100 kilometres up above our heads, and causes the gas there to glow slightly. And that's actually what gives the aurora that you occasionally see in the UK.
Auroras are considered something that, particularly if you don't necessarily live in the north of Scotland, an extremely beautiful and rare thing to actually see. But these can be dangerous as well.
Yes, aurora coincide with large-scale changes in the magnetic field, and magnetic field changes can induce electrical currents into the ground. These are normally very small, but when you get very large aurora, then the electric fields can be larger. And the electric fields or currents tend to flow through the rocks in the ground, but if they become large enough, they can then flow through into the power system through the transformers which are connected into the ground.
Approximately how many of these power station transformers are there around the UK?
There's approximately 600 at the moment, and they stretch all the way from the very north of Scotland all the way down to the south coast of England.
There have been occasions around the world, famously one in Quebec, where these produce more than just a brief power outage, don't they?
Yes, so the very famous incident occurred in Quebec in 1989 where a very large geomagnetic storm, the largest one in that decade, caused a transformer to trip in Quebec, and then there was a chain reaction event all the way down the east coast of the US. And a similar incident occurred in Sweden in 2003, and that was again a geomagnetic storm triggered a collapse in a transformer which then caused all the electricity in the country to fail.
So how likely is that to happen in the UK? Is it a real possibility?
It's very hard to say how likely it is. At the moment we're just trying to identify where it might occur, and that's what our map has tried to do. So our map is basically a very simple representation of the UK power grid. And what we do is use the geology of the UK, because that is the controlling factor actually, to try and figure out how the electricity flows between one part of the UK and another when there's a very large geomagnetic storm. So we've discovered that the extremities of the grid are the bits that are most likely to be affected by geomagnetic storms.
And by extremities you mean, say, maybe Cornwall, for instance?
Yes, so the north part of Scotland is where the electricity tends to flow into the grid, and then it'll tend to flow out at the other extremities, such as in Wales, in Norwich and in Cornwall.
Does that mean that the type of rocks in those particular areas, like Cornwall, like East Anglia, are the same? What type of rock are we talking about?
Rocks have different electrical properties. So if you have a hard rock, like a metamorphic rock or a granite, for example, it tends not to conduct electricity very well. So the electrical current will tend to flow along the surface. It's much more likely to then flow into the power grid. Something like chalk or sandstone, which tend to be what the south of England is made from, is actually more porous. It tends to have a little bit more water in it, and so the electricity will tend to flow deeper into the ground, and that way it will sort of avoid flowing into the national grid.
So you now know then which parts of the UK are most at risk, because this map that you've produced never been done before. What can the power companies do about it?
One thing that they're going to do is install monitoring equipment at certain regions that are more likely to be affected. Over the years, they do know that geomagnetic storms cause problems, but they've never been able to understand quite where the problems are. So this map will help them identify which regions they should be installing equipment in, and also which transformers they should be monitoring more closely for signs of damage, for example.
Now, the sun famously has its sort of 11-year solar cycle. I assume this affects the possibility and the number of geomagnetic storms that you get during these 11 years as well. So what part of the cycle are we currently in?
So we've just come out of a very deep sort of low part of the cycle, and we're moving through the sort of middle part of the cycle, and it will peak in 2013, around about mid-2013, and then it tends to fall off again.
So this, in fact, is perfect timing then. You've produced the map with 2 years' notice, effectively, for the power stations to act on your information and your advice.
Yeah, that's correct. This has been driven from government level, actually. There's been a lot of concern in the last couple of years that natural hazards to the UK have maybe not been studied as much as they could have been. So this is all part of just looking at what natural hazards there are threatening the UK at the moment, and as solar or geomagnetic storms are one of them, we're looking at ways to try and understand and alleviate those effects.
Kieran Beggan from the British Geological Survey. And that's it from the Planet Earth podcast from the Natural Environment Research Council. Don't forget to visit us on Facebook and do follow us on Twitter. I'm Sue Nelson. Thanks for listening.